the Human Analytical Services Laboratory in Ottawa, Illinois. And we'd like to be able to show you a few things about what we're all about, who our customers are, and the importance of the data that we provide from this laboratory.
Hello, I'm Nathan. We're here in the log room, and I have here a sample that is from the Emmett plant. All the plants send their regular samples here, and this is where I will log them into our computer system, and once I do that with the barcode, it'll fill in the testing that is needed for this particular sample. So let's go ahead and do that. Just as easy as scanning the barcode. And here it is. This particular sample needs only these two tests. So once it's logged in here, outcome labels. And these labels will be used to indicate the testing that's required, and it will go on to the rest of the lab to be tested. Okay, so we have our sample in the top of the splitter here in the hopper, and once I pull this gate, it's going to divide the sample in half, and each half is representative of the entire sample. Alright, so we have our two halves of the same sample. This half here I'm going to put in my retain cup in case it needs to be retested for whatever reason. We will have some of the original material here at the lab that we can use. Alright, and here's the rest of our sample. Now for this particular test, XRF chemistry, we want about 10 to 15 grams that will be analyzed. So I'm going to keep splitting this down. That is much more than 10 to 15 grams. So I will keep halving it until we get to where we need. Got a smaller portion now. So I'm going to go to the smaller splitter. And once again, okay, we got 14 grams. That is plenty for our XRF chemistry. Into the envelope it goes. And next step will be to grind it, and then it can be analyzed.
Pat is performing the LOI test, which is a loss on ignition. She will weigh up the sample ahead of time, put it in the crucibles. Now she's putting it in a 1,000-degree oven where it'll remain for 30 minutes, and it'll burn off any organics that might be in the material. So she'll weigh it again after it's been fired, and the difference in weight will determine the percent organic material. The silica sand itself will not be changed at all by the 1,000-degree oven.
This is the density separator test. I've got 3,000 grams. I'm going to load it into the machine. This is a program that'll make a 54 mesh cut. It runs for about 8 minutes. Fully automatic. You start the timer and it starts the pump. The fines are going to go up over the top, and you can see the course circling around down here, and we'll end up taking those off the bottom at the end. The screens catch the fines, the water gets recirculated. You can see the heavy particles are staying at the bottom. The water's letting the real fine material come up over the top, and you got the real fine overflowing into the screens. After 8 minutes, then we'll shut it off. At the end of the test, we let the coarse 54 plus 54 mesh particles out the bottom. And the finer 50 minus 54 mesh come out over the top into the streams.
So first you gotta turn our water pump on so we can get the water flowing through the system. Then we'll use our hose to wash in our sample. Once that's in, I'll start an 11-minute timer. So we're gonna let it run for a minute, let it all get through all the pumps, make sure it's not gonna rope through where it's coming out in a steady stream. Rinsing the rest of it with a water bottle here. And then right when we're at our 10-minute mark, that's how long we want to run the cyclone for. So all we gotta do is take our hose here, which is spitting out all the fine stuff that we don't want, and move it on over. And then anything that we don't need, like the slimes or the really fine stuff, is gonna go out. And anything that's less than that we do want is gonna just keep cycling through for the 10-minute process. So when the time is up, we just simply put the hose back in. We'll move our cyclone over, rinse out the funnel as best we can, get all the sand down, and our cyclone will deposit the sample into our bucket. It'll start to run clear. You can start to wash down anything that's left here. And then we'll sort of feel, if we feel any sand, we'll let it run a little bit longer. And when it's done, just pump the hose off.
So right now I'm adding the ground sample with lithium borate to be fused. Once all of the crucibles are filled and the molds are ready, you can start the fusion process. Now that the fusion is complete, we are going to extract the glass beads from the mold.
My name is Yesenia, and I will be loading the brooder with the fusion beads that we just made.
On the screen we see a sample that's getting analyzed by the XRF. The X-ray tube is shooting X-rays at the surface of the sample, and then the elements that are present in the sample are shooting their characteristic X-rays into the detector. This instrument analyzes the elements in a sequential manner. Currently it's analyzing titanium, and then it'll move on to the other elements. Hi, my name is Karthik Raman. I will be analyzing samples on the ICP for elemental chemical analysis. The samples that I'm analyzing right now are actually low iron dolomite samples from Sibelco. The sample has been prepared by a technique called as liquid fusions. The sample is then taken in by the ICP, where it goes through a very high temperature plasma. The liquid sample vaporizes, and the elements that are present in the sample, they emit a certain characteristic light, which is analyzed, and we know how much of the element is present in the sample. The sample that we are analyzing right now for iron, titanium, aluminum, magnesium, calcium, sodium, and potassium.
This is Ethan, and he's performing an API 19C standard test called acid solubility. He's going to pour the acid in with the sand now, and that's been pre-weighed. And it's going to sit in a water bath for a half an hour, at which point in time the acid can do its work on whatever is inert inside the sample. Silica sand shouldn't lose any weight, so anything that does lose weight in the acid is considered acid soluble and not desired in the proppant industry. Ethan's going to filter the sand and rinse the acid off of it. When it's completely filtered, he'll dry it and he'll weigh the sand again, and whatever weight was lost from his first weight till after the acid bath is the percentage acid solubility. There are specifications for proppant up to 30-50. Can't have more than 2% acid solubility. 40-70 is a 3% specification, and as of yet 100 mesh does not have a specification.
Clayton Chapins, I'm analytical chemist. I'm going to run a 8K, 8,000 PSI API crush test. An API 3050 sieve, I'm going to get the insides material to prep and split for the crush test. Let's see, there we go. Brush the first one. I'm using the uniloader right now to load the crush cell. We'll put it on the press and then run the sieve after to get the fines. I'm doing the post-crush sieve to determine the percent fines, and that'll be what reports to the pan. So I'm simply just going to unload this cell. This is after the post-crush sieve, and I'm just gonna measure the weight in the pan. Okay, so I gotta brush out all the screens and get the weight in the pan. This is what I wanna measure.
Carla Reese, and I am making you a coal box test, and I am doing, it's part 1 resin, and it's 705, and then the other one is a part 2, and it's 305, and what I do is I put the sand in here, and I use part 1 in there first, and they do it for 1 minute in the bowl, and then I mix it, and they switch bowls, and I mix it for another minute, and then I put the part 2 in, and I do the same thing with each of the times. And after that, I basically put this finished sand into this tube, and I come over here. And once we finish mixing, I put it into the tube, and right now I'm blowing air through it, and it blows for 1 second. Then I add the TA, triethylene gas. And right now, this is the gas line, I will be putting this in. And the low pressure gas, it goes for 1 second, and the high pressure gas goes for 5 seconds. And then it purges just air through there for 15 seconds. And then you have a core. All right, after I make the cores into the coal box, I put in here. This is a tensile strength, and it's going to put tension on the core, and it will eventually break.
The reading is the percentage that the sample is collapsed during the ramming process. So this one was at 32% compactability.
My name's John Stanger, and I'll be working with the surface area and porosity machine today that measures the surface area of clay and ground silica samples.
We do surface area testing for our clay plants as a support to them. We also use it for measuring foundry sands and competitive sands because the surface of the sand can determine its tensile strength.
My name is Nate Holmes. I'll be demonstrating the operation of the sulfur analysis.
So we have a program that ensures that the plants are running good sieve distribution, so the particle size that they say they have actually matches the UASL. So we have a sieve standard program where they'll run material through their stacks, send that here, we'll run it on our stacks that are traceable back to our master stack that gets sent out for annual calibration. And that ensures that the plants will always match us, and that hopefully that the plants will always be able to meet specs and take care of their customers as well. If we ever have an issue, we can always back them up because we know that they're getting good quality sieves through us.
Pete's performing the color brightness test. We're doing this on ground silica, ground nepheline cyanide, and on clays. Most recently, the Troy Grove plant has just started up a new process of milling Minix 4 from Canada, and we've helped with Pete especially has helped with the project by every evening testing their samples so they have results in the morning to know if they need to make adjustments to the startup. That was done all last week and it ended up being a successful week. These things are important because they'll go to paint customers such as Sherwin-Williams, where the color and brightness are very important. And Caesarstone is another customer that gets ground silica, and they need to have these results, and we provide them. We support the plants in many ways. Routine testing of their shipment samples is done by the UASL, as the plants usually can only do particle size analysis and occasional XRF chemistry. We do the whole suite of testing that they require for all their specifications. We provide support for the plants, for their sieves. We provide support and help with their XRFs and maintaining the calibrations so they know what their chemistries are as they're operating. We also have a plant lab audit team, of which many of the people here at the UASL are a part of. Right now we're in the middle of a round robin with Sibelco Europe, doing some low iron dolomite testing. We support our R&D functions as well as some of Sibelco's global R&D functions.
Thank you for spending some time with us today. We appreciate the opportunity to show you everything we have to offer, and if you ever have any questions or you need anything, please let us know.